Hello and welcome back to Fireside Math Chats with Mr. Precalc. Last time that we were here, we talked about some of your more basic trigonometric equations, and now we're going to take some time to talk about some of your more advanced trigonometric equations. So we're just going to sort of jump up a little notch in terms of difficulty and talk about some problems that are a little bit more complicated. I tried to take care of the glare and apparently I failed, so that's unfortunate. That'll be something that I keep on working on, see if I can get that taken care of. But you should be able to see reasonably well. We have, as our first problem, this thing that says 3 times the tangent of 2x equals -3. And at first glance, this doesn't look very complicated. If you were looking at this, they'd probably say, well, that means that the tangent of 2x is equal to -1. Pretty straightforward. And so if I was asking for all the answers in between 0 and 2 pi, you might look at a unit circle and say, well, in terms of my unit circle, I know that tangent equals 1 here. I know that tangent equals 1 here. This is at pi over 4, and this is at 5 pi over 4. And you might be tempted to say that then those are your answers. But remember, in this situation, this is what you're taking the tangent of. And so what that means is that 2x would be equal to pi over 4 and 5 pi over 4, which means that x would be equal to pi over 8 and 5 pi over 8. And those would be the answers that you're looking for. And if you were looking at a situation like this where you wanted the solutions between 0 and 2 pi, remember, there are infinite solutions to this equation. We could go around again, which means that rather than being at pi over 4, this would be at 9 pi over 4. And rather being at 5 pi over 4, this would be at 13 pi over 4. And you might say, but Mr. Precalc, 9 pi over 4 and 13 pi over 4 are not between 0 and 2 pi, and you'd be right. But I don't need them to be between 0 and 2 pi because they are not x. So if I put 9 pi over 4 here and 13 pi over 4 here, those aren't what my solutions are. My solutions are those numbers then cut in half. So the values that I would want are 9 pi over 8 and 13 pi over 8, which means that my equation up here actually had 4 different solutions. So that's sort of neat. Let's look at another problem. And let's take a look at this second one that says that we're going to have 10 sine squared of x minus 12 sine of x minus 7 equals 0. And in a previous lesson, I talked to you about how we could do this via factoring. But sometimes factoring might not work very well, in which case we're going to do this using the quadratic formula. So instead of writing it this way, let's say that it said 10a squared minus 12a minus 7 equals 0. If we were doing this with the quadratic formula, we would have positive 12 plus or minus the square root of 144 minus 4 times 10 times -7 divided by 2a, which is 20. Now remember, this is what a would equal. And a is the sine of x. Now this is not going to be a particularly nice number. 4 multiplied by 10 is 40, and 40 multiplied by -7 is going to be -280. So we're going to take 144 plus 280, and so we're going to end up at 424. So we have 12 plus or minus the square root of 424 divided by 20. And this is what a is, and a is the sine of x. Now, this is not a pleasant number, and because it's not a pleasant number, this isn't going to be a pleasant number either. And so what we're really going to be interested in is the fact that x is equal to the inverse sine of 12 plus or minus the square root of 424 divided by 20. And that's something that we would then use our calculator with. If we used our calculator with that, we would actually end up getting two solutions. One of those would be x is equal to 25.44 degrees. Oh wait, nope. Because what this ends up coming out to right here, this gross looking number, this thing becomes two different values with a positive sign versus a negative sign. So one of the values that this comes out to is 1.6296. And the other value that this comes out to is negative 0.4296. This value I like. This value I do not like. The reason that I like, I'm not sure how I just said that, but this value is okay. Sine can come out to a value that's in between 1 and negative 1. So this thing right here is all right. Sine can't come out to a value that's larger than 1, which means that this isn't going to actually end up producing any solutions, so we don't care about that value. It's not going to produce any legitimate solutions. Now, if we take the inverse sine of that value, that negative 0.4296, we're going to end up with, let's see, 205.44 degrees. Or we're going to end up with negative 25.44 degrees. That's what we're going to get. So if we take the inverse sine of this thing, we're going to get negative 25.44 degrees. And let's say that we were looking for solutions that were in between 0 and 360 degrees. If that was the case, this number doesn't qualify. It's not in between 0 and 360 degrees. However, remember we said these were the more complicated ones, and there's a reason for that. Negative 25.44 degrees is roughly here on the unit circle. Well, there is a number that's in between 0 and 360 degrees that would meet my requirements, and that would be whatever 360 minus 25.44 degrees would be. Additionally, there's another value that has the exact same y value. Because I'm looking at sine, I'm looking at for values that share a y value. And so this thing right here is at 360 minus 25.44, so that's going to be at 334.56. So x equals 334.56 degrees. And if this reference angle right here is 25.44 degrees, I could find another solution by taking 180 plus that 25.44. So 180 plus 25.44 would become 205.44 degrees, which means that I end up with two solutions that make this thing work. As I said, more complicated problem. So as you get into more and more advanced trigonometric equations, we have more and more stuff to look out for. The last one is even more fun. So if we look at this last problem, 2 cosine squared of x tangent of x equals tangent of x. Once again, we talked about this in my last video. A lot of you will be tempted to divide by a tangent, and unfortunately we can't do that. If you divide by a variable, you eliminate potential solutions. Anywhere that tangent of x would have equaled 0 is no longer a valid solution, and that's a problem because some of our solutions actually come from tangent of x equaling 0. So even though a lot of you will want to divide this side by tangent and this side by tangent, don't do it. It doesn't work. You lose some of your solutions that you want. Instead, bring everything to one side. And that gives us something that looks like this. And now, we got to figure out how we can solve this thing. And I want you to think, if we're not dividing by tangent, what's something we could do? And so some of you might notice that this thing is set equal to 0. And we like the fact that things are set equal to 0 because if they're set equal to 0 and we can set it up so that things are multiplying, then we can solve the equation. Right now they're not multiplying, they're subtracting. But is there a way that we could write it so that things were multiplying? And if you were thinking factoring, then you were absolutely correct. We can factor out a tangent of x. So that'll become tangent of x multiplied by 2 cosine squared of x minus 1 equals 0. Now we have two separate things that are multiplying to make 0. So we have two mini problems. We have tangent of x equals 0, and we have 2 cosine squared of x minus 1 equals 0. So to solve this, we're interested in where tangent equals 0. Well, that's going to happen anywhere y is 0. That's going to happen at 0 and at pi, and technically at 2 pi if we're including both 0 and 2 pi. And this thing, we'd have cosine squared of x equals 1/2, which means that the cosine of x equals the positive and negative square root of 1/2. And so if we take the square root of 1/2, the square root of 1 is 1, the square root of 2 is the square root of 2. Well, hopefully we recognize that this is the same thing as the square root of 2 over 2. So cosine actually equals the square root of 2 over 2, positive or negative, in a lot of different places. If we think back about our unit circle, that's been coming up a lot. We equal the square root of 2 over 2 here, 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 and here. That's at pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths. Which means that in this particular problem, we have, depending on whether you include 2 pi or not, 6 or 7 different solutions that will make this problem work. So hopefully this gives you guys a little bit of an introduction into how to solve some of these more complicated trigonometric equations. I'll be happy to go through more problems as people ask about them, but I hope everybody is doing well. I hope you're enjoying your time at home and that you're staying okay. I look forward to a time when I can see all of you again. Be well, everyone, and I'll talk to you soon. Bye.